Welcome to Virtual Labs at National Institute of Technology, Karnataka. In this tutorial, I'll show you the experimental procedure for flow through Venturimeter. This is the experimental window. Aim of this experiment is to calibrate Venturimeter with different beta ratios. Beta is the ratio of throat diameter to pipe diameter, and to determine the flow head relationship, and to determine the effect of Reynolds number on coefficient of discharge. Let us see how to do experiment with this simulation tool. This is the line diagram of Venturimeter. This is the Venturimeter. This is the manometer connected across the Venturi. Fluid flows through this, and the required flow rate of the fluid is set using a rotameter by opening the valve. Let us come to the experiment. Select a nominal pipe diameter. Select some 1 inch, that is pipe diameter, this diameter, and select throat diameter. Let us enter some 1.5 centimeters, that is this throat diameter, and choose type of Venturi. Select some welded tube type and select a fluid, water, fluid which flows through this Venturi. This is the benefit of virtual labs. You can make any fluid flow through your pipe, which is not feasible in real world experiment. Enter a flow rate, something like 1 liter per minute, by opening the valve, and HG manometer, connect HG manometer. Click the button, calculate dP. This is showing 0.17 centimeters of manometric fluid. First CCl4 manometer will use. This 0.17 is the difference between the fluid in both the limbs of manometer. Then set another flow rate by opening the valve more. For that, reset and enter another flow rate, something like 5 LPM. Same procedure, reset, and do the experiment with some 7-8 readings with CCl4 manometer. Reset, 20, reset, enter some other flow rate, 25. Yeah, it is showing up some error. Manometric fluid is overflowing. Okay. At higher flow rates, this CCl4 comes out of the limbs, overflows. So this CCl4 manometer should be replaced with HG manometer. So change it to HG manometer and proceed the same process. Calculate and reset, enter some other flow rate, 35 LPM, like this. If you want to see the flow rates and pressure drops, what you have entered and what are their pressure drops, click the button display results. These are the flow rates you have done experiment with, and these are their corresponding pressure drop. With this data, users are supposed to calculate Reynolds number and coefficient of discharge. I'll show you some sample calculations. This is the data, diameter of the pipe and diameter of the Venturi throat, 1.5 centimeters, that is nothing but 0.015 meters. Density of CCl4, density of HG, density of the fluid, and viscosity of the fluid. Our fluid is here water, density and viscosity. These are the values we have entered and their corresponding pressure drops. Let us do some sample calculations for flow rate 25 LPM. Pressure drop at 25 LPM is 59.79 centimeters CCl4. This is the pressure drop. And volumetric flow rate in meter cube per second. Let us follow SI units. And this is the pressure drop in meters of water column. Can be calculated using this formula. And average velocity through the throat is volumetric flow rate divided by cross-sectional area of the throat. Cross-sectional area of the throat is pi by 4 dt square. dt is the diameter of the venturi throat, 1.5 centimeters. Beta is the ratio between throat diameter to pipe diameter. And Reynolds number at the throat is dV rho by mu. D is the diameter of the throat, V is the velocity, this value, rho is the density of the fluid, here water, mu is the viscosity of the fluid. And coefficient of discharge can be calculated like this. Q is the volumetric flow rate, AT is the cross-sectional area at the throat, this one, and beta is the diameter ratio, 2, G is the gravitational constant, delta HW is the pressure drop in meters of water column, this one. After entering all these values, CD is coming to 0.84. Like this, calculations can be done for all the flow rates. These are the calculations for all the flow rates. After calculating Reynolds number and coefficient of discharge, plot a graph between Reynolds number and coefficient of discharge on a semi-log scale, and log for Reynolds number, and plot a graph between flow rate and head, delta H CCl4 and delta H Hg manometer. The plots would look like this. These are the calibration plot for Hg manometer and CCl4 manometer for Venturimeter. After calculating all these things, Reynolds number and coefficient of discharge, one can cross check their calculated values with simulator calculated value. For this can be done using self-evaluation. Go to self-evaluation. Enter integer values for Reynolds number. Enter values for coefficient of discharge up to 4th decimal. Okay. Select the set of readings. We have two sets of readings. One is with CCl4 manometer, one is with Hg manometer. Let us select CCl4 manometer. These windows can be resized according to our wish. These values will enter and check whether the entered values are correct or not. At flow rate, let us resize this window still more. At flow rate 10, Reynolds number is 14154. Coefficient of discharge is 0.8184 till 4th decimal, and click the button next. Go to next flow rate 25. Reynolds number is 35386. Coefficient of discharge is 0.8430. Click the button next. Like this, all the values can be checked. And now select HG manometer set of readings. Enter a flow rate 35 and its Reynolds number at this flow rate is 42463. Sorry, I have entered some wrong value here. At 35 flow rate 49534. 49534. Coefficient of discharge is 0.847. Like this, all the values can be cross-checked. 45, 45. I have entered 45. It is showing up some error, not an experimental flow rate with HG manometer. We have done experiment with only 30 flow LPM, 35 LPM. So if one tries to enter any flow rate with which experiment is not done, it shows up error. After entering values and after checking, click the button Comparison Plots. It gives a plot between Reynolds number calculated by user, Reynolds number calculated by simulator. If both the values are coinciding, the points would lie on this diagonal line. But here points are away from the line, means calculations are not correct. We can see there is a lot of difference between these two values. And same with CD, coefficient of discharge. And then click the button CD versus NRE. This gives a reference plot for CD versus NRE. This blue color line is the simulator calculated values. Pink line is the user entered values. And at any point of time, and one more thing, click the button Marks Obtained. You got 0% marks in this session. Okay. This gives, because none of your values are matching with simulator calculated values, so it is showing 0% marks. At any point of time, if you want to go to main experiment window, click experiment. This is the main experiment window. This is how you will do experiment with this tool. Thank you.